we've got questions and answers. I'm going to start over here because you had your hand raised when I was on my way up.
Yes, sir. The gentleman that just spoke, that $31 and some cents on corn, what part of that do you feel that they didn't understand the carbon penalty cover crop? Didn't utilize nitrogen well?
So that $31 on corn, that was a baseline number for year one in corn. And keep in mind, by year three, the corn is getting back to break even, and then year five, we're getting a net return on profit. Maybe I'm not understanding your question.
That's not my point. If the first year, how many people understood the carbon penalty with the cover crop? In other words, getting the nitrogen out to that crop early to make up for the microbes and bacteria that break down.
Right.
Didn't understand that. Most of the early cover croppers don't understand.
Well, I'm sure there are some, but again, we're just looking at what numbers we were provided back on the survey. But I think you have a good point there.
For either Keith or Rob, when you're looking at the cover crop systems where you're integrating grazing into that, how do you balance that biomass removal and still have a good weed suppression that cover crop when you're integrating cattle?
Yeah, so Keith can take a shot at it too, but of course it depends on what weed we're talking about. So the big three for us, at least in the Midwest, are mare's tail, which is usually a winter annual weed. So even if we get fall growth and then graze it, we'll usually have suppressed the initiation and early growth of that mare's tail. Now on the other hand, we're not having as much biomass left on the surface, so that's going to have potentially a not positive effect on things like water hemp, or other summer emerging weeds. So if we're looking at cereal rye, because of the allelopathic properties of the rye, both from the above ground biomass and the roots, we could still see some weed benefit even in the grazing, but it's just going to depend, I think, on the weed species you're looking at. But
yeah, and a lot of it has to do with timing too. You know, the timing of when the weeds are coming versus when your cover crop is up and going. If your number one goal is supplemental grazing and you start grazing that, you know, when it's only, 18 inches tall or something and you're taking it way down, you're not going to get a lot of weed suppression. So you have to balance the goal of weed suppression with the grazing goal. And again, a lot of that has to do with timing. As a general rule of thumb, you want to leave at least 50 to 60% of the biomass out in the field. Now, if you trample that down, that still counts as being left. If you can maintain 50 to 60% of that out there, you'll still have some weed control, but there's certainly going to be some gaps out there. I can tell you from experience, it is better to not graze than to graze it poorly. And what I mean by grazing it poorly is you take away too much, because you will set your soil back by doing that, mostly because you're removing all this residue and you're leaving the soil bare and susceptible to blowing and washing and things like that. So poorly managed grazing is probably worse than not having grazing at all. And we're good examples of that on our own farm. So I know that from experience.
Can I just quickly add something to that too? When you're looking at that as well, it doesn't mean that you need to graze the whole entire field. You could manage your grazing in such a way so that where you may have more of a weed issue in a certain area of your field, you could change the grazing rate or not graze that area at all. So, exclude that area from grazing, fence that area out or something like that, so that you're able to keep the weed biomass. Again, these are tools, so you can just figure out how to manipulate the tools to achieve the goals that you want to achieve. And Keith was right in trying to be able to look at what your goals are, but I think you can have your cake and eat it too if you just look at how you want to manage your tools.
Okay, so advice for sowing annual crops for vegetables without tillage on a small scale. Right.
yeah, so I work with the USDA SARE program, and some of the farmer projects we've been funding, it's been interesting lately on small-scale vegetables with cover crops that people are doing no-till with any type of cheap material they can get to cover the ground and terminate the cover crop without disturbing the soil. So I've seen people use old billboards or other waste plastic material, and they're just laying it down and covering it for 2 to 3 weeks until that cover crop is terminated, and then coming in and planting into it. But Others of you have comments?
Well, you've got the opportunity this afternoon to listen to Steve Groff, who is probably, one of the best guys I know of that is doing it. He's maybe doing it on a larger scale than what you are, but he certainly has a ton of experience in that. But it just comes down to management, and on a small scale, you can do like what Rob was talking about. There is small scale equipment that you can get, 5-foot cover crop rollers and different things like that to roll some of that down on a small scale. But I would definitely make sure you get to Steve's talk this afternoon, because he'll address that.
And I would also mention Brian O'Hara, B-R-Y-A-N O'Hara. He has lessons online on YouTube about 4 acres or 3 acres of no-till vegetables that he does really well. A lot of examples of ways that you can do it. So he's a great resource, and so is JM48 in Montreal has some great information on that too. So those are 2 people.
Well, and I would also say that, we talk about no-till, and I think that there are very good aspects with no-till. And again, looking at that trade-off, like I said, about it ripping off your limbs and those types of things. When I've worked with some vegetable producers, organic vegetable producers, it's not exclusive that you absolutely have to have no-till. And especially in this area of the country, you're looking at sort of an old growth forest environment dealing with very large perennial weeds that grow very tall, issues with the amount of precipitation that you have that adds a lot of additional stressors. Humidity in this environment is different than it is in the Midwest, and definitely different than it is in Nebraska. So as we look at how we're going about managing it, again, going back to this whole trade-off idea, when I talk to vegetable producers, if you're going to do tillage, I'm not going to tell you not to do tillage, because you have to do what you have to do. But what I want you to be thinking about is, again, how many times are you going to go through and rip off my limbs if I'm a mycorrhizal fungus? So if you're going to go through and do tillage, I'd rather see you, people talk about, well, I just do shallow tillage. Well, if you do shallow tillage 5 to 6 times a year, that's ripping off my limbs every single time. But if you do a deep tillage once a year or once every 3 years, I can recover from that if you're going to incorporate cover crops and doing all of these other steps along the way. So when you're thinking about it, think about it as a trade-off as well of that carbon flow, where that carbon's going to come from and where it's got to go to. And can you compensate for that tillage?
Okay, so the question has to do with cover crops as a means to remediate stratification in a no-till system.
We've been no-till, some of our ground's been no-till for more than 30 years, and I don't think that we've seen that stratification issue, primarily because we have so much earthworm activity that we're getting a lot of that nutrient distribution through the earthworms. And so, we've even applied surface applied lime, we surface apply compost, manure, all those different things, and we never till or incorporate it. So a lot of it is going to be biologically incorporated through earthworm activity. And the other thing that you'll find is that when you have a very healthy rhizosphere ecosystem and you've got that good thatch, good cover on top of the soil, roots are going to grow where there's moisture. And if you've got moisture right at the top of of your soil profile, because you've got good ground cover there, you'll have a huge amount of roots right there taking the nutrients from the very top. You don't have to drive them down deeper. In a conventional till system, you do, because there's no moisture at the top. You have to get it down deeper because that's where the water's at. So again, that's why it's important to keep the soil covered, because you'll maintain good moisture at the very top where your nutrients are. So we probably almost see the opposite sometimes, is that you have some nutrient leaching down deeper, and you'll need some of those deep-rooted cover crops to go down and recover those and bring them back up. So the tillage radish, the ryegrass, some of those things with the deeper root systems can help bring some of those nutrients back up. But you may see some nutrient stratification issues early on when you're doing it, but I think once you get into a system like this, we haven't really seen an issue. I don't know, have you guys seen anything on the places you've been?
And I think that, another thing to do is looking to it, the cover crops that you're choosing and where their root mass is going to be if you do have an issue with stratification, because especially early on. I think I agree with that. As you progress into the system, it's not necessarily going to cause those same types of issues. But early on, looking at the cover crop choices that you have, looking at some things, if you've got some issues with phosphorus, which, are issues here on the Delmarva Peninsula, utilizing crops like buckwheat within that system, utilizing some other crops that are going to be able to help you to manage putting those nutrients not just in the roots, but also in the foliar tissue. So choosing your cover crops judiciously.
Hi, Chris Lawrence with NRCS Virginia. I have a quick comment and then a question. So I taught a 3-hour class on cover crop planting yesterday. It was pretty well received, and one of my messages was the best way to learn is to pick plots, small or big. And I told that because I learned that way. And Keith, I want to tell you that part of the reason I learned that is the seed you sent our way a long time ago. And I don't know if I've ever talked to you since, and thank you. But I want everyone here to know if you like the class I taught, it's in part because of your generosity years ago. And so, you help public sector folks learn so that I'm not charging anything to speak here, and I'm turning that around. So thank you for that, and for everything you and other folks, Keith Robb as well, have helped me. So if you like what I taught you yesterday, you need to thank this guy. My question that you can repeat if you need to is you said something about earthworms and soil testing that really captured sort of my thinking, which is that don't worry too much about fancy soil testing if you don't have earthworms yet. You don't want to focus on getting those earthworms first. I'm interested in what Kris has to say about that comment. Thank you.
I think that, again, looking for those indicators that are talking about biological activity, so earthworms could be a good indicator. I think that there are, and I just got done doing some workshops, mostly in Canada, but elsewhere in the United States as well, where trying to develop and discuss various types of tools that you can utilize on farm. And basically utilize household materials to do some things like separating out soil aggregates, which is, I think, as I mentioned, one of the best tests that I find too is looking at water movement, infiltration rates, and water holding capacity. Soil aggregation and measuring aggregate stability is one of the best soil health tests, and there are ways in which you can do that utilizing some very simple tools. I'm going to have some stuff up on my website soon. I'm also doing some work with a company called Food Water Wellness Foundation, nonprofit up in Canada, and we're putting some stuff on the website. We just did a 3-day workshop on doing some things with these different types of tools to do that, as well as to measure things like so soil aggregation, water infiltration, water holding capacity, kind of simulated rainfall simulator types of things to be able to take a look at that. But also mycorrhizal colonization methodology that you can utilize household chemicals and household tools to be able to do. So I think some of that's kind of coming online and would give you some good opportunities to talk about and show these things in biologically active soils. Last one.
So for someone who's doing cover crop for the first time, how long after the termination of the crop would that nitrogen that is captured, such as legume or whatever it's holding, how long would that be available to the plant? Would it be something with early in the growing season, late in the growing season, not until next year's crop?
So when is nitrogen released following the termination of a cover crop to the next crop?
It depends on a lot of things. Primarily, the most important thing would be what was the carbon-nitrogen ratio of that cover crop mix, because that has everything to do with how quickly that will release. And depending on how fast you do want it to release, you can kind of make your cover crop mix to try to hopefully hit the windows that you're looking for. So on our Smart Mix calculator that we have on our website, it's trying to predict what that C to N ratio is going to be. And that's really important, because if you need it to cycle really fast, you need to try to keep your carbon-nitrogen ratio probably 20 to 25 or less if you want it to turn over pretty quickly. And there's some instances where you would want that. If you don't want it to, then you need that C to N ratio to be higher, 25, 30, 35, something like that. So like with soybeans, you don't want that nitrogen becoming available until later in the season. With corn, you do want it to. So the two things that influence carbon-nitrogen ratio are, number one, the plants that you have. Of course, legumes are going to have a much lower carbon-nitrogen ratio than the grasses and the broadleaves. And then also how long you let it grow, because even cereal rye, when it's really small, is going to have a very low C to N ratio. So if you're spraying out or tilling under or whatever, how you're terminating, cereal rye, when it's quite small, the C to N ratio on that, it might only be 18 to 20. But if it's 5 feet, 6 feet tall and you're planting green, that stuff might be 65 to 70. And so there's a huge range there. So it all has to do with how much carbon to nitrogen ratio is there that determines how quickly it breaks down. Kind of as a rule of thumb, what we tell people is if you have a cover crop mix, you could go out there and take a clipping of all of the biomass that you have, send it into the lab. They could tell you not only how much nitrogen is in there, but they'll also tell you what the C to N ratio is of that actual biomass. Kind of the rule of thumb that we use is if it's 25 or less, we figure that probably 50% of the nitrogen is going to come available for that crop that's growing in there next. If you start getting up above 25 and up into the 30s and 35s, that's going to take far longer to cycle and come through. Now, the other caveat to that is if you're tilling it under, if you're doing an incorporation of some kind, you're going to greatly speed that process up versus if you're just crimping and rolling and leaving it on top of the soil. So I guess that's kind of a long answer to it depends, but those are the factors that you really need to look at when it comes to that nutrient cycling. And that's hugely important, especially in corn, as this gentleman over here was talking about the carbon penalty. There can be huge penalties in using cover crops and in a corn system. You have to adjust when you're putting your nitrogen out there. You can't just put cover crops into the system that you're already using without changing other parts of your system. Otherwise, it's just going to be a train wreck. There's other changes that have to come along, management changes that come along. I love and I don't know if Steve Groff is here yet. He's speaking this afternoon. I love it when Steve says cover crops will make a good farmer better and a bad farmer worse. And it's because a bad farmer is not going to apply the additional management that it's going to take to make those cover crops work the way they're supposed to.
So I want to thank the speakers from this morning. We appreciate you guys very much and all the information.